Alright, we're going to talk about sections 2.4 and 2.5 in the book. 2.4 defines our 6 trig functions, expanding from our 3 that we talked about before. And 2.5 is a little more interesting, talks about inverse trig functions. So let's begin with our coordinate definition of our trig function. So if I have the coordinate uv, a distance r from 0, and angle theta in standard position, we know that sine of theta is v over r. Cosine of theta is u over r, tangent theta is v over u. And we look at the reciprocals. So reciprocals are 1 over the quantity, which gives us our other 3 trig functions, which is not the same as an inverse, as we'll see in a minute. So we have cosecant of theta is 1 over sine of theta, which flips sine of theta to be r over v. Secant theta is 1 over cosine theta, equals r over u, and last one is cotangent theta is 1 over tangent theta equals u over v. So those are just defined values. We plug through them and we can get out what we're doing there. Let's talk for a second about inverse. What does that mean? Well, if I take something and I perform an operation on it, I get something else. Well, if I want to undo it and get back to my something, I need an inverse. So that is my inverse operation. They produce an identity. They produce the same thing. I come back to my original starting point. Alright, so if I look at sine of theta, well, if I think about what is my domain, what am I plugging into sine function? I'm plugging in angles. And it gives me a ratio. Or if we're talking about our coordinates, we're talking about coordinates. If I wanted to go the other way around, inverse, I would want to have to put in a ratio, and I'm going to get out an angle. So let's think about sine of 90 degrees. Well, if I think about where I am coordinate-wise, I'm straight up, I'm going to get a sine of 90 is going to be 1. So sine inverse of 1 has to give me the angle that produced 90. There we go, right? Well, there's a slight problem. We expanded our domain to include any angle. So this is still true. Sine of 90 plus 360 is sine of 450, should also be 1. If you did it with a calculator, sine inverse of 450 should give you 450, but it doesn't. It still gives you 90 degrees. And there's a reason why we do this, because we want the inverse to be a function. We want something to give a one-to-one mapping. We put one thing in, we get one thing out. So what we end up with is a restricted domain that still gives us all the values that we need, but when we turn it around and look for an inverse, we get our one thing back out. Alright, so let's look more specifically about what this means. So again, remember we had this coterminal definition for phi and theta where we have multiples of 360. Well, if we look at our axes, and if I think about restricting the domain, alright, there's theta that goes from negative 90 to 90. And if I think about sine, is going to be within that domain. From 0 to 180 is going to be cosine. Let's think about what's happening here. Sine's the y-coordinate. This gives me the full range of y coordinates, right? X coordinate is cosine. This gives me the full range of possible x coordinates. So I don't need any other angles. I can go any angle in there and any distance and get any x coordinate that I would like. Going up and down, I can, between negative 90 and 90, I can go any angle, any distance to get any y coordinate that I want. Alright, well, what about tangent? Alright, if I take a point u, v, u over v is, in this case, is going to be tangent, and it's going to be positive over negative, which is going to be a negative result. If I have u prime and v prime, where the magnitudes are the same, but the distances are different. So if I think about the magnitudes, that's u, it's the same, and that's v, it should be the same. Those are my magnitudes or my distances. U prime over v prime is positive over negative, which is still a negative result, and in the end, it's the same value. So we restrict the domain for tangent to the same thing that we do for sine, between negative 90 and 90. Alright, so let's solve a problem. How are we going to do this? If I look at piece by piece, cosine of 0 degrees, we're going to find that to be 1. Okay? Because if I go out any distance, the distance r is going to be the same thing as my x-coordinate, so that's 1. What about sine inverse of 1? Well, the question now is what angle, when I plug into sine, gives me 1? Well, that's going to be 90 degrees. Let's look at another one. Sine inverse is giving me an angle. So what I want to know is tangent of that piece. Alright, well, I know somehow I'm going to get an angle that gives me that tangent value. That sine value. So root 2 over 2. And I can solve for x with the Pythagorean theorem and get that x is also root 2. So tangent of that angle is going to be opposite over hypotenuse, or my u-coordinate or my v-coordinate. Either way, it's going to give me root 2 over 2. It's an isosceles triangle, and I'm going to get 45 degrees as my angle. So this whole thing has to equal 1. And it equals 1 because tangent of 45 degrees is root 2 over root 2, which is going to be 1.